Hello, this is Dr. Mears. Today we are going to be learning about volume. We are in 3 dimensions now, as you can see our 3-dimensional figures. I will be teaching you how to make a 3-dimensional cube and these 3-dimensional prisms. We have been working on cylinder in class, so that's the first one that we're going to start with. So here we have a cylinder. Think of a soup can. I love soup. I eat it every day for lunch. Sometimes I'll make it. Sometimes I'll get it out of a can. So that's what a cylinder is. We have our radius here as we work to remember area, where we have our radius is half of the diameter, and we have the height of our cylinder. And our height, I just actually wrote it so it's out here. The height is actually from that middle to the top of the can or the cylinder. It's how tall that cylinder is. Our volume is pi times our radius squared times our height. And I wrote a little key up here, so if you forget what R is or you forget what H is, everything is up here for you. So let's do an example where we find our volume, and please remember, I should have wrote this up here too, use pi to equal 3.14. It'll help us in our rounding, especially for those of you doing my project. So here we have an example of a cylinder. We have a radius of 4. We have a height of 6. We need to find the volume. That means if we were to pour liquid in here, say, fill it up with some soup, how much soup is actually going to be in our can? So I did it in inches, so let's see, that's a lot of soup in inches. It's probably going to come out to be a big number. So we're going to do 3.14 times our radius, which is 4 squared, and that is in inches, inches squared, so everything would be squared, times 6 inches. This is a 6. So our volume here, you can do this in your calculator. I highly suggest using your calculator because you can do the squared in your calculator. Oops, I'm sorry. You may do the squared inside your calculator, and I don't want you to make arithmetic mistakes. That's why I'd rather have you just do it all in one step in your calculator and calculate it out to 301.44 inches. Because we are in 3 dimensions, it's cubed. Because we squared inches here and we're multiplying it by another one, we're actually doing inches times inches times inches. That gives you inches cubed. That means we're in cubic units. So we have cubic units because we are dealing with volume. So 3 dimensions, cubic units are cubed. All right, let's learn how to make a cuboid. A cuboid, or otherwise known as a cube, has all equal sides. So what we want to try to do is start with a perfect square. This is probably not a perfect square. I tried though. That's the key word, is try. What you want to now do is overlay another square that overlaps it so that this should be in the middle of your previous one. It's difficult to do, I know, but we're going to try our best. Here we go. So we have 2 squares. One overlaps the other square. Try to get it kind of in the middle. And you're going to connect each corner. Once you connect each corner, you're going to start seeing the 3 dimensions pop out at you. Those 3 dimensions being length, width, and height, in which we get our volume of length times width times height. So let's try our example. In a cube, all the sides are equal. So here in our example, if this was 4 and these weren't filled in, I would know they would be 4 too. Our length is 4, our width is 4, and our height is 4. And they're all dealing with inches. Okay, so let's calculate our volume. Our volume is going to be 4 inches times another 4 inches times another 4 inches. And here we see really nicely how we're multiplying inches times inches times inches. So when we do that, 4 times 4 times 4, or 4 cubed, is 64 inches cubed. And that's going to be the volume. Say if this was a pool, we would be filling up 64 cubic inches of water into this pool, into this cubic pool, which would be cool. Okay, so there's your volume of cubed. Next are prisms. Now, there's many different types of prisms, but they all have the same formula, and I'm going to show you that formula. Notice there is a new letter here. This is that fancy A. If we go back to the top of the paper to my little key, A is going to represent area of the base, and this is what we're going to have to find with our prisms, and that's why I'm having us make them so that I can point out what the bases are so that we can find those areas of the bases, and then we multiply it by the height. So let's go and do that. So first is a rectangular prism. So rectangular prism, very similar to the cube, but what we want to do is we want to make two squares, but put them farther apart. The farther apart you go, the longer the length will be, the longer the height actually, the longer the height will be of the prism, the more rectangle it would be. So you're going to do two squares, and then you're going to be connecting them, connecting their corners. And again, once you do that, the 3 dimensions will pop up. There we have our rectangular prism. And so here, in order to find the base, we have to locate the two sides that have the same shape. So what do I mean by that? Well, here we started off with these two squares. These two squares, these are our bases. So notice this shape opposite is the same. These two are squares. So that green part, that is our base. So for this one, since our bases are square, our area of our base equals length times width. And so this is going to be length, and I'm actually going to write it over here. This is going to be width. And then this is going to be the height of how tall our prism is. So you have to find the base, and that's the area of the base. That's that fancy A right here. And I'm going to write that volume equals area of base times the height. So that's what that fancy A is. Let's do a triangular prism. All right, triangular prism. I'm going to do a nice right triangular prism, which means that this is a right angle here. So we draw two right triangles pretty far apart from each other. And then again, yes, connect, connect, connect. And what you have is your triangular prism. And the reason why it's called a triangular prism is because your bases are the triangles. So you have to look for opposite sides that have the same shape. Here we have one triangle, opposite we have the other triangle. So our area is going to be of our triangular base. So here we have our bases. And the area of our base here is 1/2 base times height. So here's our base, here's our height, and then here is the height of the actual prism. So don't get confused with these two right here, okay? This is just of that triangle. And you can even do a little triangle here, you can do a little square here. That's fine as well. Okay, let's do a trapezoid. So trapezoid, you have to make two trapezoids. This one's a little bit harder. And make another trapezoid. And I like to move it over just a little bit and move it back and over just a little bit. So two trapezoids. And then we connect them. Connect, connect, connect. These do take practice. I'm not testing you on your art skills here, but I do want you to see that the reason why this is called a trapezoidal prism is because our bases are trapezoids. These two sides opposite right here are trapezoids, and so that is our base. So the area of a trapezoidal base is 1/2 A. This is A on top, base 1, plus B. B, this is base 2. And then times our height. And the height is going to be how tall this is. So times our height. And then we also have the height of the prism, which is this. So you do have to be careful because you are working with a couple different heights. You're working with the height of the base, and you're also working with the height of the prism. Your height of the prism, height of the base. Height of the base, or actually now it's width, and then we have height of the prism. So depending on which one we get for an example, our area of the base formula is going to be different, which is this right here. Remember, it's area of the base times the height. So let's see what we're given. And this should be a little, okay. Ooh, we're given a triangular prism. So one, we have to locate the bases. I see that we have two triangles here. So we're working with our triangular prism. So I'm going to have to do the volume. I'm going to have to find the area of the triangle. Area equals 1/2 base 4 times 2 height. So 1/2 base times height. Base times height. Now I have to multiply that by the height of the entire prism, and that is my 6. You may use 1/2 or you may use 0.5. Please make sure if you do use 1/2 in the calculator, you are putting parentheses around it. If you do not, you are going to get the incorrect answer and be marked wrong. So pretty please make sure you have parentheses around this 1/2 times 4 times 2 times 6. And we're going to get 24 inches cubed because we are dealing in volume. Okay. Our next ones, we have our right pyramid, our cone, and our sphere. So our pyramids, these are different from prisms because they only have one base, which is really good. Remember, fancy A is area of the base, and H is height. So first let's make them and then we'll do an example. I didn't even list an example there. Okay, so to make a rectangular prism, draw a rectangle or square. Actually, I think we might go with a square pyramid. Sorry, to make a pyramid, I would start with a square as best as you can. Then after you draw the square, what you're going to do is you're going to take each corner and you are going to bring it up to a common point. This common point has a really cool name. It's called an apex. You're not going to have to memorize that, but if you see it, you now know what it represents. And there you have your rectangular pyramid. Remembering your base is this square or rectangle. You have length and width, and then the height is how tall it is. And I'm just going to label the height outside as just how tall your actual pyramid is. You're going to be doing the same for a triangular pyramid, which is also called a tetrahedron. Again, really cool name. Just want to let you know. And this little point right here, apex, in case you wanted to see it spelled out. All right, so we start with a triangle, and what we're going to do is we're going to come up to that common point again, bringing each corner up to that common point or that common apex point. Please notice this is our base, and you are going to have to be given we are going to have to find the area of our base. It is a triangle, so you're going to have to be given this height, and you're going to have to be given this base. And then we also have the height of the pyramid. Okay, let's calculate one. So our volume is 1/3 times the area of the base. So we have to look to see what base we're dealing with, and then the height. So here's our example. Let's do that rectangular prism. Let's draw a nice square, connecting everything up to an apex. We're going to put a length in of 6 inches. We'll put a width in of 4 inches. And let's make this 8 inches tall. All right. So now let's get our volume. So first we have to locate our base. Our base is this bottom piece. We only have one of them. This base is a rectangle. Yay! 6 times 4. So let's put that in. Volume equals 1/3. Notice I'm already putting parentheses around it. Times area of our base. Area is length times width because we have a rectangle. So 6 times 4. And then times the height of our pyramid, which is 8. Volume equals, I'm going to put my 1/3 in parentheses. If you don't, you get the wrong answer. You could use 0.3. It won't give you as great an answer. 0.33 would probably, but I'm just going to do this. 1/3 times 6 times 4 times 8. I'm going to get 64. Great. So we get 64 inches cubed. And these should all have inches as you know, inches times inches times inches. So the volume of our pyramid is 64 inches cubed. Let's move on to our cone. I think this is a little bit easier. Here's your height. So we have our cone here. I just did an upside down V in a circle. Our radius, our height. We're going to do for volume 1/3 pi r squared. We see where this comes from times our height. So volume, we need an example. Let's draw our cone. Let's give a radius of 6 inches. Let's give a height of 12 inches. And let's proceed to find our volume. So 1/3. And everybody, I hope you're realizing that that's actually the area of a circle. So it is the area of this base is pi r squared. So it is the same exact formula that we were using for our pyramids, except they do always like to put in this pi r squared instead of the fancy a. So I'm not sure. Remembering pi is 3.14 times 6 squared times 12. These are inches, inches squared, inches. All right, parentheses around this. Let's put everything just as we see it in our calculator so that we do not make any calculation errors. So here I go, 1/3, 3.14, 6 squared, and 12. Let's see what we get. 452.16 inches cubed. So if we were to fill this whole cone up, that's a lot of inches. It would take 452.16 inches cubed if we were to put something in there. And last but not least is our sphere. We only have radius. I think this is the nice easy one. What I do is I just draw the circle and then I do a little dotted line in back and solid line in front. We're going to do 4/3. So be careful. This is 4/3 times pi times r cubed. Here's our example. Oops. So let's do a radius of, let's do 12. Let's see what happens with 12 and 12 inches on that. All right, so volume equals, I'm already putting my 4/3 in parentheses, times my 3.14, and then my radius is 12 cubed. So volume equals, and I'm going to show you how I'm putting this in. So first I'm going to put in 4 divided by, just use my division sign, 3 times 3.14 times 12. Now I need the third power. This is my exponent button. Above my division sign is my exponent button. You push it, it goes in the exponent position. I push the 3, I push the over arrow to close my parentheses, and now I'm good to go. There we go, rounded to the nearest hundredth for us. This is a huge sphere. Not forgetting, this is inches cubed. Your 12 is getting cubed and your inches are getting cubed. So 7,234.56 inches cubed. This is a pretty cool number if you look. 2, 3, 4, 5, 6, 7. Isn't that pretty cool? So I notice things like that. And so this has been volume of a few different solids. Hopefully it helped. Thank you.